Warning. This is an important announcement. MP Birla Planetarium is preparing for a liftoff. All systems activated for launch position. T-minus 20 seconds. We have the OK for liftoff. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The control center wishes you an enjoyable flight.
Planet view रहा है.
Welcome on board the MP Birla Planetarium. Please make yourself comfortable, recline your seat, and enjoy this journey through space and time. Our flight will take you through the infinite vastness of space and into the fascinating world of planets, stars, and galaxies. We are now at the parking orbit around the Earth. Look at the star-spangled sky that surrounds our planet. As you enjoy the view, we will tell you a little more about our destinations on this amazing journey.
Once we leave the Earth's protective atmosphere, thousands of stars appear in the heavenly darkness of the sky. Our early ancestors were fascinated with the starry night sky. Out of the scattered stars, they created groups that formed patterns, the constellations. Astronomers have divided the entire sky into 88 constellations. In winter, we can see truly impressive constellations in the northern hemisphere. For example, in the constellation Taurus, we find Pleiades, the Seven Sisters. The brightest star in this stellar formation, Aldebaran, emits a reddish-orange glow. One of the most beautiful constellations in the night sky is Orion, with its brightest stars, Betelgeuse and Orion. Below the three stars that form Orion's belt, a softly diffusing flow can be seen, the famous Orion Nebula. Castor and Pollux are the brightest bodies in the constellation of Gemini, and Sirius in Canis Major appears from the Earth as the brightest star in the sky. A nebulous, dimly glowing band runs through these constellations, the Milky Way. Now our starship moves moves towards the constellations, which we would be able to see from the southern hemisphere of our home planet. In the constellation Carina, we find Canopus, the second brightest star in the night sky. During his circumnavigation of the globe, the Portuguese navigator Fernando Magellan discovered two cloud-like formations in the sky, which we call the large and the small Magellan clouds. A well-known constellation can be seen here, the Southern Cross. This constellation was once used by sailors for navigation before the invention of the compass. Right next to the Southern Cross, we can see the Centauris. The bright stars Alpha Centauri and Proxima Centauri are the stars closest to planet Earth.
The Planetarium spaceship moves back in the direction of north on its orbit of our planet. We have now arrived back over the northern hemisphere.
Three bright stars, in particular, pierce our view of the summer sky. Deneb in the Cygnus, Vega in the Lyra, and Altair in Aquila of the Eagle. They form an unmistakable isosceles triangle, the summer triangle. Right overhead, you will notice a group of 7 bright stars, the Big Dipper. If we extend the line connecting both these stars, we would eventually reach the North Star, the brightest star in Ursa Minor, the Little Dipper. We can use this star to determine the direction of the north, and therefore to establish all the other points of the compass. In addition to the starry sky, we can also observe other celestial bodies. The planets, Mercury, the bright light of Venus, also known as the morning star or the evening star, and Saturn, whose rings are actually visible through a basic telescope, and Mars, identified by its reddish color. Finally, you will recognize Jupiter here, and our moon, which we can only just see as a crescent.
The moon is our closest neighbor in space, probably created by the collision of a massive protoplanet with the Earth over 4 billion years ago. Its surface is studded with impact craters and covered by a layer of debris and dust. In the springtime of our solar system, the moon was hit by a large number of meteorites. However, the moon also bears the footprints of the astronauts who were the first humans to walk on the moon a generation ago. 5 American flags that the astronauts rammed into the surface of the moon during the Apollo missions are still standing today. However, the flags have now been bleached white by the unfiltered light of the sun that reaches the lunar surface.
When we once named the stars and the planets, we encounter many mythical figures from the imaginary world of our forefathers. Countless myths from earlier periods in human history give us insight into the feelings and thoughts of humans from bygone times that were dominated by gods, monsters, and heroes. For example, we have the hero Hercules and numerous beasts that he must conquer in the 12 insurmountable labors, such as to slay the Nemean lion, whose pelt made it undefeatable against any weapon, or the constellation Hydra, which tells the story of the many-headed water snake.
The preparations for the rest of our flight are now complete. Our journey of discovery through the vast cosmos can begin. In just a few moments, we will leave Earth and set our course for Venus. The Venus Express, the last space probe, took 153 days to reach this planet. But in the empty Birla Planetarium, we only need a few seconds to do so.
Our neighboring planet has long been considered as the twin sister of the Earth, as both are highly similar in terms of size and mass. Like the Earth, the Venus has a dense atmosphere, but its blanket of cloud belies a highly hostile environment. Radar images show a rough surface with large plains and few hills or valleys. The highest plateau is referred to as Aphrodite Terra and is actually an extremely inhospitable place. The dense atmosphere of the Venus consists of carbon dioxide, and acid rain falls from its clouds. The dramatic greenhouse effect of the carbon dioxide atmosphere makes it the hottest planet in our solar system, with a surface temperature of 500 degrees Celsius, hot enough to melt lead. A few 100 million years ago, the planet had major volcanic activity, and lava flows have been discovered which are longer than the longest rivers on planet Earth. It is possible that there are still active volcanoes on the Venus today.
Now you have discovered Venus, a highly hostile and inhospitable planet. In our journey through space, Mars, our next door red planet, is welcoming us.
We have now reached Mars after passing its two small moons. The moons Phobos, meaning fear, and Deimos, meaning terror, are named after the companions of the Roman god of war, Mars. The rust-red color of the Mars is due to the iron oxide in its rocks and soil. The surface of Mars is covered by deserts of sand and rocks, and a thin atmosphere causes many unusual meteorological phenomena. The planet has seasons, and during the summer on Mars, temperatures can reach well above 10 degrees Celsius. Then even the polar caps of frozen carbon dioxide begin to fall, as in the area around the US Mons Mountain, weather phenomena are everywhere. Dust devils swirl across its red surface, and great dust storms periodically rage blot out all that lie in their path. Global storms can go on for months and cover almost the entire planet. There is enough evidence to conclude that eons ago, liquid water did flow on the Martian surface. Images and soil samples taken by the Mars rover show smoothly weathered stones and gravel which could have only been formed by the action of flowing water. Could life occur here? Are there perhaps still basic life forms below the surface of Mars even today? The search for traces of life and water on this planet is one of the main tasks of the Mars rover. And this is the hopeless endeavor. Research by the German Aerospace Center has revealed that there are in fact terrestrial life forms which could survive for at least a certain time on Mars. In experiments, certain Arctic lichens were able to tolerate the extreme temperatures and the thin atmosphere of an artificially created planetary surface of Mars.
Now we say goodbye to Mars and continue our journey. Our starship is now approaching Jupiter. Its striped structures mark the tops of enormous cloud systems. Its striped face marks the tops of enormous cloud systems. All the structures, stripes, cyclones and spots on its face are changing constantly by the force of incredibly powerful storms. Jupiter is the largest planet in the solar system, and our Earth can fit in here 11 times over. It has completely different characteristics than all terrestrial planets. Jupiter is a giant ball of gas and devoid of any solid surface.
Over 60 satellites are prisoners of Jupiter. The four largest satellites of the planet were discovered by the Italian astronomer Galileo Galilei in 1610. As we see, moons are eclipsed by the shadow of this giant planet before they disappear behind it. Shadows of the moon are moving on the face as they transit in front of Jupiter. Although these moons orbit the planet very close to each other, but they're different in character. We saw these moons through the eyes of Voyager's probe's camera. Io is similar to our moon in size. Its active volcanoes spew multicolored sulfur snow into the sky and then drifts downward to repaint the landscape. Ganymede is Jupiter's largest moon and the largest in the entire solar system. Its surface is formed from highly polluted ice.
Our flight through the world of planets continues.
Saturn is the second largest gas giant. Saturn is smaller than Jupiter, but quite similar in many ways. Like Jupiter, Saturn has no solid surface, and a vast ocean of liquid hydrogen surrounds a relatively small core. The wind speeds in its atmosphere even exceed those on Jupiter. Saturn is the Lord of the Rings, the jewel of the solar system. It has over 1,000 individual rings, which in turn are composed of countless pieces of ice. How are these rings actually formed? Are they debris from the impact of two moons caught in the gravitational pull of Saturn? Or made from the raw material of an additional moon which has not been born as yet? We really do not know. Saturn has now lost its unique order. Ring structures have also been observed around Jupiter, Uranus and Neptune. However, they are not quite as pronounced. On changing our flight path, we speed on to the outer limits of our solar system. In just a few seconds, we have covered more than 1 billion kilometers. We are now flying past other planets. The gas giant Uranus, with a sideways axis of rotation tilted by over 98 degrees. It also has a faint ring system. Neptune, the eighth planet and the farthest from the Sun. Its atmosphere consists mainly of hydrogen and helium.
The dwarf planet Pluto, which is smaller than our moon, is a member of the Kuiper belt, the icy fringes at the outer edge of the solar system.
Please take a look back at the beginning of our journey. We have visited the planets Mercury, Venus, the Earth with the Moon, Mars, Jupiter, and Saturn. They orbit the Sun at varying distances and different speeds. Their invisible pull of gravity is instrumental in the movements of all the celestial bodies in the solar system. Beyond Saturn's orbit, Uranus and Neptune orbit the Sun. It is observed that Mercury, as it is closer to the Sun, moves faster than the Earth. On the other hand, all the planets beyond Earth's orbit move slower as they are further away from the Sun. However, other than planets and their moons, there are billions of space rocks that we sometimes call asteroids. They follow their own elliptical orbits around the Sun. Most asteroids lie in the asteroid belt between the orbit of Mars and Jupiter. Due to Jupiter's massive gravitational pull, they can be dragged out of the orbit and as a result come perilously close to the Earth. Then there are also meteorites, small celestial bodies which often cause shooting stars as they enter the Earth's atmosphere.
And the comets, because of their unexpected appearance in the sky with long cloudy tail, terrified the human mind. They were generally thought to be ominous portents from the heavens. However, astronomical research has now dispelled their former reputation. Some comets appeared at regular long intervals, like the famous Halley's Comet, which emerges in every 76 years.
With a circumference of 109 times as compared to that of the Earth, the Sun is unique and different from all other bodies in the solar system.
All other bodies.
With a surface temperature of 6,000 degrees Celsius, our Sun is a ball of glowing gases. No solid earth within, nor in a liquid either. Our Sun is a star. The star shines and even emits light to illuminate planets. The Sun affects life on Earth in many different ways. Without the Sun, the planet will be a cold, lifeless chunk of rock, and life would never have been able to evolve or flourish on our planet at all.
During the previous flight, you discovered our closest cosmic home, the solar system. Now let us discover the realm of the stars and open up a rather unfamiliar world. We will cross vast distances far beyond the power of human imagination.
In space, the unit used to measure an astronomical distance is the light year, the distance it takes for light to travel 1 year. In just 1 second, a beam of light crosses a distance of around 300,000 kilometers. It takes about 1 second to travel from the Earth to the Moon. The light emitted by the Sun reaches the Earth in about 8 minutes and hits the nearest star after more than 4 years. When you look at the stars, you will notice how some are brighter than the others. You will notice their difference in color. Like the planets, the stars are different from each other in terms of their size, mass, or temperature. Red stars are relatively cool, such as Betelgeuse in Orion or Aldebaran in Taurus. An extremely hot star, however, is the bluish-white Rigel in Orion. The brightness of the stars, as perceived by the human eye, is dependent on the size of the star and its temperature, but also on its distance from the observer. At first sight, stars will appear to be lone bodies, but with the help of a pair of binoculars from the Earth, many binary stars can be observed. However, star clusters are even more fascinating. In the next destination on our journey into space, we will reach Pleiades, the seven sisters in the constellation of Taurus. In just a few seconds, we have traveled a distance that light would need several hundred years to cover. This open star cluster doesn't contain only 7 stars, but in reality, more than 500 that are surrounded by clouds of gas and dust.
As the Pleiades disappear from our view, I would like to draw your attention to another nebulous formation. Now, we have crossed another 1,000 light years to observe the Orion Nebula, an expansive complex of bright, gaseous and dark, dusty material.
The Orion Nebula is one of the most famous and the most active stellar nurseries. Here, dense masses of gas and dust of inconceivable dimensions clumped together, giving birth to new stars. The space between the stars is never entirely empty. The clouds of material surprise us with an impressive diversity of forms, such as the North American Nebula in the Cygnus constellation. Or the Horsehead Nebula in Orion. At many locations in the vast expanse of the cosmos, in the gigantic clouds of gas and dust, new stars are born even today. But stars do not last forever. Stars are born, they live, and must die in millions or billions of years. Stars with a large mass undergo a particularly dramatic death. At the end of their life, they eject most of their material into space in gigantic explosions. This increases the brightness and becomes as bright as an entire galaxy. New stars and planets are born from the remains of these stellar explosions. Every single element that forms our planet and human life was forged deep within this cosmic furnace. Today, astronomers are constantly discovering new planets in orbit around other stars. But in time, perhaps, we will discover the Holy Grail, the discovery of a second Earth in orbit around a star like our very own Sun.
We continue to advance even deeper into space. Please direct your gaze to a new object. Our flight is now taking us past a stellar cluster.
Hundreds of thousands, even millions of stars have joined together in a compact formation. Here, predominantly old red stars are held together by gravity. Stellar clusters are perhaps the earliest objects in the Milky Way that formed along with the very first stars. They are a highly common phenomenon, but how they actually came about is still a puzzle. Our starship is now in extragalactic space. A slowly revolving spiral-shaped object appears in our field of vision, the Milky Way, to which our Sun belongs as well. as one of over 200 billion stars. Our solar system is located at the edge of a spiral arm and orbits the center of the galaxy once every 220 million years. Our galaxy is in no way the only one in the universe. There are around 100 billion galaxies in the cosmos, and these occur in an impressive diversity of forms. Spiral galaxies, barred spiral galaxies, elliptical stellar systems, and galaxies with irregular structures such as large and small megalithic tracts.
Now our starship will journey back home.
In our flight through the solar system, we observe the planets, asteroids, and the moon, our closest cosmic neighbor. Traveling through the galaxies, we have learned about the relatives of the Sun, journeyed through star fields, and discovered groups of stars, the star clusters. In the space between celestial bodies, we have observed enormous clouds of stellar nurseries, the birthplaces of the stars. About 5 billion years ago, our solar system emerged from an interstellar cloud, and in a process that took millions of years, our home planet was formed. Today we discovered planets that are orbiting other stars, but we still explore to dig out other planets with the rhythm of life that orbits some other stars. Our Earth, the home planet, has been capable of sustaining life for the past 4 billion years. Life has evolved from the most primitive living organism all the way to the complexity of human beings. Our early ancestors were fascinated with the star-studded night sky and movement of the planets in graceful arcs, and waxing and waning of the moon excited man's imagination. In the process of understanding his own world, human beings gradually explored its structure and laws that act within it. Cosmic nebulae in dazzling colors, thousands upon thousands of galaxies, countless stars, and hundreds of planets have been found. And yet, there is still no other planet which is quite as diverse, as stunning, or as breathtaking as our planet Earth. One day, perhaps, we will really stain our space shoes with alien dust of one Earth-like planet. Nevertheless, we should honor and take care of our precious oasis of flourishing life, floating like a bright blue dot in the vast emptiness of the infinite cosmos.
For re-entry into the Earth's atmosphere, our starship has arrived in the orbit. Please be in your seat, rest, keep it at upright position and fasten your seatbelt. We will land in a short while. Attention please, our landing sequence is being initiated. The parachute has jettisoned. And the brakes are firing. That was a perfect landing. Please remain in your seats until the lights come on and do not loosen your seatbelt until